So, oops, sorry about that. Here we go. All right, so when you hear CAD and 3D modeling, often they're kind of interchanged together, but there's actually a slight difference. And often when you hear 3D modeling, like if you create a 3D model or you use programs like Maya or Blender to create these 3D models, it's more like you're forming digital clay. You're sort of free form, you're sculpting the shape, and it's really good for organic shapes, things like faces or models with 3D textures, and actually creating those and customizing all the kind of tuned little pieces. However, it's not as optimal for creating precise shapes like an engine if you wanted to, for example. CAD, however, is great for creating an engine because you actually specify geometric shapes. So you use parameters like dimensions and length and width and angles so to actually specify what the geometric shape will look like. So that's why they call it a parametric design, because it's actually using parameters. It's really not optimal for making kind of organic, freeform sculpted shapes, but it is, again, optimal for making solid brackets, things around the house if you're going to 3D print. And ultimately, that's kind of our goal here with this class, is to just not only introduce CAD, but sort of show you that you can use these tools to create things if you then send it to a 3D printer, and then now you can start repairing things around your house. And we think this is really important to be able to do, instead of just throw away something, be able to repair it at home or upgrade it even. And so you do that with CAD and 3D modeling too, but in general, with 3D printing, you can upgrade things. And so one of the big differences between 3D modeling and CAD is 3D models are made up usually of a bunch of small triangles called like a mesh. So it's kind of like this net casted around the shape, and some places have a little higher density amount of these triangles and some places have lower density. But the point is, it's kind of made up of all these triangles that just sort of wrap around that shape, and it makes it a little more difficult to actually modify it. Like if you want to change the length of this face here and or pull it out a little bit, you have to be a little more clever when it comes to dealing with these meshes. And so that's where CAD comes in, because instead of being represented by a bunch of triangles, it's actually represented by the boundaries. It's called boundary representation. So it actually specifies faces, edges, points, and uses those to actually mathematically generate curves and faces and what you see here. And so it's a lot more precise, and not only that, it's a lot easier to, for example, extend this face out or just modify the part. Not to mention the precision is there when you actually want to go back and change a dimension in order to update the entire part, like move this hole's location or shrink the hole or extrude this face out. So it's a lot easier to go back and make modifications for and make different iterations. And so, just to confuse you guys even more, both CAD and 3D modeling can output a 3D model for 3D printing, as I mentioned, and that is usually an STL file, which stands for stereolithography. And that output, the confusing part, is that outputs a mesh. And so it's really hard to go from this mesh file, this STL, back to a CAD file. It's kind of like going from a PDF back to a Word document. It's a lot easier to go the other way. So just keep that in mind. Often right now, a lot of these files are sharing for 3D. And one of the drawbacks is they don't come with any information on color or tooling. Like if this was supposed to be cut out with a CNC mill or some other kind of manufacturing, in addition to being 3D printed, it doesn't have any information for changing tools. And so people are now, kind of industries, larger industries, are creating new standards called AMF and 3MF formats. Those are going to include a lot more information than the standard STL file. But for now, what you'll find online is going to be STL files, which are meshes. And so if you get one of these and you try to edit it and you realize, oh, it's kind of difficult. Why when I pull up this face, it's only pulling up this single triangle? Well, that's why. So I'll get a little bit more into that in a minute. But before I do, I wanted to explains sort of the idea that there are no wrong answers with CAD or 3D modeling. There are multiple approaches to the same exact 3D model, and here's an example of that. For example, these are three different ways to make a basic 3D cylinder. First way is you can just add a 3D cylinder in most programs where you just specify a radius and a height and just add it to the scene, and boom, you have a cylinder. Another way is, and this allows you to do a little more customization in the actual shape, but you can draw a 2D circle and pull it up into a 3D cylinder called extruding. So it's called an extrusion. You usually just 2D sketch something and then you extrude it out into a 3D shape. This could be a star extruded out into a star 3D shape. It could be anything. Another way, a little bit more advanced, is you can also sketch just a basic square and a single axis, vertical axis, or this pole to then spin that square. This, you can imagine sort of sweeping this square around 360 degrees fully in order to trace out a cylinder. Or maybe if you only trace it out 270 degrees, it looks like a wedge of cheese missing a slice of cheese or something, or a cake missing a slice. And so there's different ways, and this is sort of different than typical ways of thinking. So kind of when you first approach it, you might just think, oh, I need a cylinder, let me just throw in the cylinder. But if you just add a bunch of primitive shapes together, it often becomes difficult to create more complicated models. And if you get used to just doing adding cylinders and subtracting them from cubes and like building things like that, you often hit a wall very quickly on trying to create complicated shapes. So that's where you kind of look at these different ways, and where you have sketching in a CAD program is tremendously useful. All right. So one last point I wanted to mention I thought is very important is calipers are your best friend when it comes to 3D printing or CAD or any of these 3D modeling, because they allow you to pick up things in real life and measure them very precisely and then enter in those dimensions as you build the 3D model. But not only that, they also kind of force you, especially if you have some drawings ahead of time, to think, okay, how do I want to approach this 3D model again? Do I want to do a 360 revolve to make that cake? Or do I want to pull up this extrusion straight up? Or how you want to approach it? And it's often important, especially if you want to reverse engineer, or let's say create some brackets for some shelf in your house, or to repair some expensive part that only has that missing plastic bracket. I've been there before. It saves you a lot of money. You can then take these calipers and, for example, measure the outside of the part and make a little drawing and enter that dimension and write it down. You can measure the inside of parts by spreading the other side of a caliper open and reading that dimension. And then one thing that often people don't know is that you can actually measure the depth of a hole by when you notice that when you open up the mouth of these calipers, or these, whatever they're called, the beaks, um, that when you open it, this little plunger pops out the bottom. You can actually use that to measure the depth of a hole. So you just place the bottom of the calipers there, open them, and then the plunger will hit the bottom of the hole, and you just read that measurement, and there you have it. And so they're very helpful, very useful. And again, it's also useful to help draw your 3D shape down first, or just kind of get an idea and think about the way you want to approach it and add the dimensions ahead of time. And that way, when you go in to sketch it and make it, it's a lot easier, it's a lot faster. And I'll be showing you again the demo about that, which we will get into right now. Again, if you guys have any questions, feel free to add them in the chat and we'll answer them as soon as possible. And yeah, so just as soon as you have a question, go ahead and enter it, and we will answer it as soon as we can. So first, I'm going to a website called 3dorchard.com. You can type in 3D Orchard and click the first link or go to it. I'm already signed in, so it automatically takes me into this home page, if you will. What this is a website that has built-in 3D CAD tools so that you can create 3D models in your browser for free without downloading anything. And not a lot of places, they kind of, or the few places that have kind of similar offerings, you can't really save anything privately for free. Well, here you can. You can build anything you want for free. Um, and it's not only just the free CAD, but it's also a whole database, a whole library of other 3D models, kind of broken down into different categories. And so you can go through here and find all these different models, and all of these were created using the tools on this 3D Orchard platform. And so the cool thing is, not only you can just see a 3D model somebody created, but you can also see a tree of its evolution. And so on the right here, you see all these different iterations and versions of this single object. And you can highlight your mouse over that tree in order to just quickly glance at what the thumbnail looks like for that iteration. And you can give approvals and you can like things, and the trees and the branches with the most likes and the most growth will be thicker, kind of like a natural tree. So you can then see the evolution over time of these 3D models. And if you come in and you have an account and you're like, oh, hey, this is cool, except for I think it should be a little bit taller, you can press this button in the bottom left. That's the common icon to enable you to go into this CAD interface. And it will load this interface for a second, and then you will be able to start 3D modeling. And so here we are. I'm going to zoom out a little bit. So this is the 3D model, and you'll notice that this interface looks like there's really nothing going on, and it's very empty. And that's on purpose, because a lot of 3D modeling interfaces that you go into, they look like you're sitting down into a jet engine cockpit, and there's just so many buttons, and it's overwhelming, and you don't really know what to do. It's hard to learn. This is the opposite of that. Instead of having to go dig into buttons and figure out what they do, and get a lot of errors telling you you can't do that, this 3D Orchard just presents you what you can do. And so I just click this 3D model and I can just see it, and I have now the option. I can move it around, I can rotate it, I can copy it or delete it, because this is in fact a 3D scene. You can imagine building any kind of 3D entire scene, maybe redo, if you want to redo your garage, for example, you could create a 3D model of it and mock it up and just say, okay, the spacing is about 5 feet here. And so that's the benefit. So in this case, I want to edit this part. So I press edit part, which is this blue button here, and it loads the part into the scene. And that helps keep it very fast for when there's lots of parts in the scene at once. And so here it is. And so now I can hover over individual parts like a face. And so I wanted to make this a little bit taller, so I click this top face. And now, because I'm editing the part, I can see different options. So I see the ability to pull this face up, which is what I want to do. But I could also sketch on it and make a little sketch to start make a custom shape onto that. I can round the edges, flatten the edges, I can hollow it out, or I can create some cross-sectional design view from that, which I won't get into for now. But to be simple, we're just going to extrude it. So I'm going to press this extrude button, and let's say we want to enter it 1 centimeters or maybe 2 centimeters, so it kind of shows you a little bit. But maybe you don't want it in centimeters. You can go to this cog and change the units, but we can also type in something like maybe 1 inch. So you type 1 in, and it will automatically translate that up once you do it. In this case, we want the whole part to go up instead of cut through something. So we're going to make sure that it's toggled to fuse, so the last parts fuse together. And we press this check mark. And so then you'll notice that now this part is extruded out, so it's like way taller. In fact, it's 1 inch taller. And so if I want to then round this little edge here, I can click it. It's kind of hard to get to, so I'll zoom in a little bit. Click the edge. Oops, just the edge. And so I have the option now. I have this edge selected. I can round it or I can flatten it. I'll just round it. Sure, 1 centimeter, that's fine. And so now you can see it's successful and it's rounded. And so here we have it, this kind of weird shape. And if I'm done, I can press save. I can press publish. And because this is a previous model, it already has a name, it has everything. So you just kind of describe, made it taller, add some tags, and save it. And because this is kind of goofy, I don't really want to do this right now, so I'll just go ahead and get out of this. Proceed. And so if I would have saved it, actually this branch then would have grown up taller, and anybody else would have seen it. Again, you can add comments to this, and you can tag it, and at any of these models, at any point along these branches, you can actually download a 3D model of it. So you can just press download, and you'll download the STL file or the base, it's called boundary representation file, which you can take into FreeCAD and turn into literally any other file type that FreeCAD outputs. So outputs. So yeah, you can download the file here and just press STL, and it'll download it. And then I can take it to my 3D printer and have this object. So it's kind of cool. I'll go back here. And so here's the main page, and at any point you can press that same icon and go in here, and now you're back in this CAD interface again. So you're right back here where you started, except there's no model. It's a brand new model. It's a brand new design. Zoom out a little bit. And so let's just show you something a little like useful. Like for example, I can make that bracket that we saw in the presentation. Like if you want to make some weird bracket, I'm going to go ahead and start by either adding, again, we can approach this in a few different ways. I can add a box and start modifying it. I can add a cylinder and just specify the height and the radius, kind of like this. This isn't a bracket, this is just obviously a cylinder. I'm just showing you can add basic shapes. In this case, I'm going to double click this part and get rid of it. Just press delete here. Because I want to make the bracket is a little more complicated, I'm going to start off by selecting one of these three planes. So in fact, I'll click this green plane, and this button pops up, which is for sketching. So I want to sketch. I want to create a 2D sketch and turn it into a 3D model. And so that little bracket was a weird L bracket. And so I'll just make it, just start kind of freehand drawing it. And when I make vertical lines and horizontal lines, they'll kind of automatically follow these grids for now, but you can also drag them and change them later, but it kind of helps guide you. So I just made a full L shape and kind of closed it, and you notice that it went from dark blue to light blue, and that meant that the actual sketch closed the loop. And that's important because in a lot of 3D modeling platforms, CAD programs, if this wasn't closed and I then try to pull it out, extrude it into a 3D model, which I'll show you in a minute, it won't work because it doesn't know how to handle such thin walls, because according to math and computers, which is what this thing is doing, it thinks that this is an infinitely thin wall, and so it just gets confused and it doesn't know what to do with it. But when it's closed, it's water or airtight closed, now it knows this whole thing's a solid part, and now it's going to treat it as a solid model, and I'll show you that in a minute. But for now, I got done drawing. So I'm going to press escape or press this little select tool. And now I can start clicking these lines, dragging them, messing with them. And when I click something, same thing with 3D models, what you click gives you the options. The options pop up based on what you click. So if I click 2, if I hold Control or Command on a Mac, which is what I have now this 2 lines selected, and there's an angle. It's already filled out showing it's 90 degrees, but if I really wanted to make sure it's 90, I can make them perpendicular. I could lock it by pressing 90 degrees, so now it's perfectly 90 all the time. I could type in a different angle between those if I wanted to make it 45-degree angle. If I want to just turn this from being vertical all the time, I want to make sure it's off, I just toggle it on and off. I can turn it into a construction line, which it's kind of advanced, but essentially it's just lines and elements that are used just to help you sketch, but they're not going to actually become a 3D model. So that's what those are. So keep that vertical. And notice that there's distances. So yeah, we'll keep this 6 centimeters and lock that in place. We'll get this is 6 centimeters, but let's just make this 7 centimeters. So you notice that got a little longer. 2, it's fine. 2 is fine up here. 4, sure. I think that's, yeah, so it's probably good. And so now that we're done, we're going to close the sketch by pressing the check mark. Don't press the X because it'll close the sketch without saving. It's just like a cancel. So again, we just single click the sketch, and this thing pops up. It allows you to then extrude it. And so we can drag it out just a certain amount, but let's just call it 6 centimeters. And so you press the check mark, and here we have it. So that 2D sketch of an L just became this like 3D bracket. And so if we wanted to modify it a little bit, maybe we just go ahead, we select this top face, and we can now just sketch on top. And it might be hard to see, but here we go. We're just gonna kind of freehand. And these grids right now are set to centimeters because the units are set to centimeters. But if I wanted these grid lines to be smaller, I can go in here and change the units down to millimeters or a different kind of unit, and it would then change this grid size. I'm not going to do that for now. So I just drew this kind of line. Again, you just press escape, get to the select. All right, this looks fine. So I'm going to go ahead and close that sketch. And now I'm going to extrude this shape down. And because I'm going to use it to cut, I don't really care how far down I put it. So I'll put it like minus, and it's minus because it's going down. So minus 5 centimeters. That's fine. All right. So now we have this, and you might be wondering what's going on. Well, the reason I created that is to remove it from this shape. So I'm going to first select the main shape that I want to keep, and then I second, holding Control, and to select it, I double click it. Then I hold Control and I double click the second shape, and now this other menu pops up. And the thing to understand is these are two separate 3D objects. If I were to save this, which often you should save, by the way, I should save this right now before cutting it, and then I can always go back to those different branches later and modify it if I need to. But if I were to save this, it's saved as two separate 3D objects, and if I were to go to 3D print it, I would have to 3D print it as two objects. If I wanted to make them one object, I would melt them together with this fuse icon here. If I wanted to then subtract one from the other, which is what we want, I would select this cut icon, which on the left it shows the solid object, and then the second thing you select is the thing that excuse me, cuts away from it. And then you could also make a comment which takes the intersection of these two objects. So just leave this single rectangular cube here in this middle of where they're intersecting. But we want to cut, so we're going to do that. If I wanted to make multiple cuts with this rectangle, I would keep it, and I would move it and make another cut, and then move it and make another cut. So I would toggle this to keep it, but I don't want to keep it. I want to get rid of it. So I'm going to just press this check mark, and boom, we have this cut made. Now it looks like one of those foam chair things. I don't know what it is, but the other part about that 3D model then needed a weird cut right here through this corner. And so I could do that two ways. I could draw another triangle and actually cut that section out just like I did with this bottom. Or even simpler, I could just select this corner here and press this little flat button and type in the dimension. But for the people who will later watch this recording and rewind it and check that and double check me, they'll realize that it's actually two different dimensions. It's fancy. So it's actually not exactly 45-degree cut. It's a slightly different angle. So to handle that, we select this face, and then we hold Control and select this edge, and now press this, and now we can do two different dimensions. So one of the distances was 1.5, and the other one was 2. And so in doing this, now we make this kind of weird, wonky side cut, and there we have it. And so again, if this was real part, I would actually be saving probably between each of these steps it's not just for you, but if you're intending to make this public and you're excited to watch the internet build it and evolve it and change it, save it along multiple steps so that people can modify it along different steps and you can watch it evolve in all these cool ways. So yeah, there's that part, and even though it's ridiculous, I'm just going to go ahead and delete it because I don't need it. I can go down here and I can add shapes, and again, I just wanted to show you some new other functionality. But if I want to go back to those sketches I used, I can go back to this add and click list sketches, and it'll then show a couple of sketches that are toggled kind of invisible, and so that just shows you again where the sketches that were used to create that. And for now, these sketches actually disappear when you save, or sorry, after you close out the application, the sketches disappear, but what you saved will remain. However, the sketches will not remain. So just keep that in mind. That's why I recommend saving very often. So yeah, we'll just hide these for now. But if you wanted to, let's just do the cylinder example that I showed you a little bit earlier, since I think we have a little bit of time here. So here's the cylinder, and I just specified a random height and radius. And so here's that cylinder. If I want to get really fancy and turn it into a bowl or something, I can actually click it here and press this hollow button, or shell it's called, and specify how thick do you want the walls of that bowl to be. Well, let's just call it 0.5 centimeters. Actually, let's just call it 5 millimeters. Just be clever. Here we go. All right, so there. So we have now a 5 millimeter thick wall, and if I wanted to 3D print this and throw stuff in it, I could. The cool thing about that shell tool is it actually will follow the contours you put. So if I want to, I'll just select that face, and what this is going to do is it's going to round all the edges near that face. So I'm going to press this. I'm sure we'll make it, actually let's do 2 centimeters. Get crazy. All right. Whoa. So now it's like a big round bowl, like a thing. And so now when I actually hollow it out, it will follow the contours of the, let's do that again, 5 millimeters. It'll follow the contours of that roundness inside. So it's kind of a round. So now it's like a Tibetan singing bowl or something. But if I wanted to make the same kind of a shape or kind of something similar, I could also approach it. Again, there are multiple ways. It's like Bob Ross. There's just happy accidents. There's no mistakes, just happy accidents. I could go back here, draw a single vertical line, select it, and again with that construction, because this is going to be the pole that I use to revolve this L shape around. So it's not going to be actually used in a 3D model, just used to create the 3D model. So here we go. I'm going to make some L shape. And if I want to make it round like that, I can just be fancy with it. Here we go. Just make it round. Go back to the lines. And again, you can sketch with lines and circles and arcs. And I can select this line and hold control and select the other line and press tangent. So I always say tangent. Specify angles. So yeah, once you're happy with that, again, this is dark, so we need to make sure it's closed loop. I'm going to make the inside just angled weird like this. I'll just make some strange jaggedy teeth angles because I can. And the coolest thing is that when I make this, I'll be able to actually 3D print this thing and have it in real life. Maybe put my fruit in it, maybe fruit bowl or something. All right, so I want this to sit on this construction line. So I'm going to hold the dot, click the line, press this button so its point goes on the line, and now it's stuck there and everything's good to go. So I'm going to close this, and I could just click this and extrude it out, but then that'd become this weird bracket shape again. But in this case, I'm going to hold control and also select that center line. And now I have this new cool thing, the revolve, which I talked about before. And I can revolve this thing 360 into this weird shaped fruit bowl thing, like that. There you go. So I could again just 3D print this, and maybe it just keeps stuff from rolling about. I don't know. I don't know what the point is of this. I just kind of made it up. But again, I could save this if I wanted to. If I wanted to just grab this face, and because I made it horizontal and it's totally flat, I actually have the option. I could extrude this face. So I don't even need to sketch anything. I could just grab it and kind of modify it. We'll pull it up, I don't know, 5 inches, 6 inches, who knows. I'm just freestyling at this point. So there we have it, apart, and let's just, for fun, we'll just flatten those edges again. Here we go, just to make it flat. Boom. So I have no idea what this is, but it's a thing. And if you get too fancy, some complex shapes are gonna sometimes break or give you an error, but for the most part, if I wanted to cut a hole through this bottom all the way through, I could just sketch. Here, I'll just do that. Hopefully, because I'm streaming, and again, this is an old 2011 Mac on a Brave browser. I mean, this is like pushing it, running on this, but all right, so I just drew a circle, and now I'm going to do something fancy where I actually just double click the part, and then I hold Command or Control and single click the sketch, and so now I've both connected. And so this now, depending off if I have cut or fuse selected, it will automatically fuse this into a long protrusion that comes out the top, or if I do pull down on this arrow or make it negative, it should cut down automatically and say cut. And so you just have to make sure it's set to cut if you want to cut something, or fuse if you want to fuse it. If I were to set this to fuse and I press the check mark, nothing would happen because I just had a 3D circle cylinder go into itself. And anyways, I'm going to set it to cut, press this check mark, and you will notice now it has a little hole in there. And so I could have actually drawn that in that revolve shape and done this shape in one step, or I could have done it like I did where I extruded it out and cut this hole, whatever. So yeah, again, I could save this, but no need. Lots and lots of parts. You can go through any of these made by anything, anywhere. That's funny. And a lot of them, you'll see the trees kind of look like this long, straight evolution because no one's come in or the other person didn't go back and change something. So I could download this and 3D print it and say, good job. In fact, I'll give them a little thumbs up here. Say, good job. There we go. Oh, here we go. Here's the comment. Cool. You can like comments, flag them, all that. So yeah, that's 3D Orchard. Again, it's all free. It's just built by actually myself and a couple of others named Patrick Galogli and Eric Strauss. And so we've been kind of working on this for a while on the side. And so yeah, definitely check it out. Hopefully it'll get better and better over time. Thank you guys so much. Really, it's been an honor. Thank you for joining this class, really. Yeah. I hope you can join any of the next ones. We do this once a month. Let us know, send us an email, contact@sporehsv.org or contact @mycelium.ngo.
Oh, we're on all the we're on Facebook, Twitter, Instagram, LinkedIn, and we post our events up there too. And our website gets it, so just check back with us.
Thank you guys.
Thank you, everyone.
Have a good day. Bye.
Bye.